Hey, we are Team 14. My name is Jiayue. My group partner is Curtis. Our project is about real estate in Melbourne, adding value via machine learning. The presentation includes three parts. The first one is about domain. What is the background of it? How about business value of it? Second part is about what we have done to do the data pre-processing and about the data visualization. Finally, we come to the machine learning models and what is the findings during training the models. As to the business value, whenever we come to a new city, finding a place to live is always the first problem is to think about. What is the normal price of this type of house? Do the landlords or the property agents offer me a fair price? We are so confused because we have no idea what is the fair range of price of a certain type of house. What if we can come out a system like if we input some important attributes like building area, the number of bedrooms, location, it will range the price of the house immediately. It will solve pretty much the problem. So we consider our domain as real estate price prediction problem. Basically, about the business values, there are three ones. Real estate analytics can be widely used by property investors and advisors. It helps understand how the overall market is performing in real estate. The models can be applied to predict property price in other cities with similar features. Let's look into the dataset. There are 20 attributes here. I only include some important ones here. Some attributes related to the location, such as suburb, address, region name. Some attributes related to the property itself, like the number of rooms, the land size, the building area. Some attributes related to the purchase, like the method of selling, the type of agent, when it was sold. Our target is to predict the price. As the dataset is not clean, there are many zero and none values. As you can see here, in terms of land size, there are plenty of non-values. We remove them. As to how to deal with the outliers, we only keep the middle 75% of the dataset and trying to make it distributed normalizedly. As I said before, there are many categorical values like the type of property, the agent. We need to make them into numeric data. We use the label encoder to convert them to numeric data. Now we come to the visualization part. It is clear that the larger building area is the price is higher. They are positively correlated. It is pretty much similar to the land size and price. The heat map shows all the attributes, how they correlated with each other. Finally, we come to machine learning models. We use three models here: multiple linear regression, random forest, and logistic regression. We use multiple linear regression because we have many attributes which impact the target price. We also use the absolute mean error to evaluate the model performance. Since it is not a classification problem, it cannot be simply categorized true and false. We use the differences between the predicted price and the actual price to evaluate the model's performance. First, we try the combination of these attributes: the region name, the number of bedrooms, the method, the distance, the building area, the types, the number of bathrooms, the car plot, the line size, and year sold. We can see the results of 3 models. The random forest shows the best performance here. And then we look into the multiple linear regression and random forest. We try some different combinations of the attribute input. We figure out that the distance has the most impact to the price. Then is the type of property. Then is the number of rooms, bedroom, building area, land size, bathroom, car plot, year sold, and method of selling. Since we got this finding for the benefit of investors, they could pay much more attention to the distance of a property so that they can get a more valuable house based on this finding. We also find that the same attribute impact the model differently. For example, the method of selling has the negative impact to the multiple linear regression. However, it contributes a lot in terms of random forest model, which means if I add this attribute in multiple linear regression, it will increase the error. While if I add this value to random forest model, it will decrease the error. Through multiple iterations and trials, we figure out the best model, that is to use random forest. And the input attributes are the following. Since we've got this kind of prediction, finally, it can be applied to 2 kinds of business model. One, this prediction service can be public service. It can be provided in official. It's to attract more property investors to the city. It can also regulate the real estate market. It can also be customized service provided by agents so that the agents can show their professional insight in the house to attract more customers. That's all. Thank you.